Hi, in this video I'm going to present an algorithm that it is used in power system analysis, especially in the harmonic assessment. What the algorithm does is just tries to determine the polygon that encapsulate all the Cartesian the points from the Cartesian plane that are given. So here we have some points. Each point representing the resistance and the reactance at a certain frequency of a contingency. So the utility actually gives all these points, and the one who does the assessment must try to find only the extremity points that creates a polygon which encapsulate all the points. Okay, so we have the algorithm here. The algorithm is called the Graham scan algorithm, and if we run the algorithm, we are going to this algorithm is going to determine the polygon, and is going to represent it here in the plot. As you can see, the extremity points are this one, and the lines is constructing the polygons, and as you can see, all the other points are inside the polygon. Next, I'm going to present in large term how the algorithm works. So first of all, the user must introduce in the point matrix the values for R and X that the utility gives for analyze. And the very first step is to determine the point with the lowest y-x value, and from all the points, this point is with the lowest y value is 69.7, 13.9, and it's called the reference point. Step 2 is to compute the angles of all the points that make with the OX axis. Then step 3 is to order all the points based on this angle. So all the points are going to be ordered from the smallest angle to the highest angle. Step 4 is to store the reference point, this one, and the point with the smallest angle, which is this one, in a matrix. In our case, the matrix is called the polygon, and at this stage it has only two values, the reference point and the point with the smallest angle. Then step 5 is to iterate throughout each remaining points according to the value of the angle. So the algorithm next is going to iterate throughout the remaining point, which is going to be this one, this point, then this point, then this point, then this point, so on and so forth until this point which has the highest angle. And step 6, in this step the algorithm is going to determine which point is going to be kept in the polygon and which is not. It is a simple rule. Actually, the procedure is a bit more complex, but I'm going to present it as a general rule. So first of all, let's rename the points. This point is going to be R0, this point is going to be R1, and this point, the first point that we are going to iterate, is going to be R2. Yes. So let's see. Now the algorithm is going to determine if R1 is going to be kept or not in the polygon. So the rule is as follows: if R2 is placed in the left side of the line that is determined by R0 and R1, then R1 is going to be kept in the polygon, and the whole process is incremented with 1. Otherwise, if R2 is going to be placed in the right side of the line determined by R0 and R1, then the point R1 is going to be removed from the polygon, and the whole process is incremented with -1. So this procedure is followed until the last point. and in this way the polygon is determined. This algorithm is very fast of determining the polygon if you have a few values for n and x, but let's see how it behaves when you have a large number of contingencies. So inside in content in points, let's append 1217 rows and paste the values. Okay, now let's see the results. As you can see, we have a lot of contingencies here beyond 1200. As you can see, that the algorithm determines very fast the polygon, the contour of all these contingencies. That's it. Thank you so much.